Hello dear students, today we are going to start with the first question of electrostatics, electric charge and field. Now coming to question number 1a, a body has a charge of 10 microcoulomb when it is moving at a speed of 50 meter per second. Find its charge when it is moving at 100 meter per second. That means when the speed is double, what is the effect on the charge? Now please remember, as far as the charge is concerned, it does not depend upon the speed of the charge. So therefore, as far as the first question A part is concerned, if it has got a charge of 10 microcoulomb at a speed of 50 meter per second, then at 100 meter per second also, it has got the same value of the charge, that is 10 microcoulomb. So the value of the charge is independent of the speed. Now coming to the B part of the question, how many electronic charges form 3.2 millicoulomb charge? Now this question is based on quantization of charge. Now what is the meaning of quantization of charge? It can be mathematically expressed as Q is equal to N into E. Q is equal to N into E, where Q is the magnitude of the charge, N is the number of the electrons either gained or lost, and E is the magnitude of the charge on the electron. So now let us note down the data for the second question, and the data is the charge that is required to be developed is 3.2 millicoulomb. Now this can be written as 3.2 into 10 raised to the power minus 3 coulomb. Now it is an SI unit, and we want to find out the number of the electronic charges which have got transferred. So N is question mark. N is what we have to find out. And what is the magnitude of the charge of the electron? It is 1.6 into 10 raised to the power minus 19 coulomb. Is that okay? So using this formula, Q is equal to ME, we can write Q is equal to ME. What we need to find out, that we should keep on one side and the other things we can take onto the other side. So we can write what is N equal to? It is Q divided by E. Is that okay? So here we can write N is equal to, what is the value of Q over here? It is 3.2 into 10 raised to the power minus 3. Q is equal to, so N is equal to Q upon E. So the value of Q is 3.2 into 10 raised to the power minus 3 coulombs, and the value of E we know is 1.6 into 10 raised to the power minus 19. So we can write 3.2 upon 1.6. Here we can write 10 raised to the power minus 3. When 10 raised to the power minus 19 goes in the numerator, it becomes 10 raised to the power plus 19. So we can write plus 19 over here. So multiply by 10 in the numerator and denominator. So we get 32 upon 16. And here we can write 10 raised to the power 60. So this becomes 2 into 10 raised to the power 16. So these many electronic charges are required to constitute a charge of 3.2 millicoulomb, or 3.2 into 10 raised to the power minus 3 coulomb. Is that point clear? So let us move to the C part of the question. So what the C part of the question states, how many electrons must be removed from a conductor so that it acquires a positive charge of 9.6 nanocoulomb. Again, the question is based on quantization of charge. So let us note down the data here. So how many electrons must be removed? So let the number of the electrons which are required to be removed be N. So N is question mark over here. And amount of charge that we want to develop is 9.6 nanocoulomb, which is 9.6 into 10 raised to the power minus 9 coulomb. Nano stands for 10 raised to the power minus 9. Alright. And we know the magnitude of the charge of the electron is 1.6 into 10 raised to the power minus 19 coulomb. Now once again, we know the formula based on quantization of charge Q is equal to NE. So what is N equal to? It is Q divided by E. So what is the value of Q? It is 9.6 here into 10 raised to the power minus 9 coulomb, and here 1.6 into 10 raised to the power minus 19. So we can write 9.6 upon 1.6 10 raised to the power minus 9 plus 19. So we have N is equal to, here multiply in the numerator and denominator by 10. So you get 96 upon 16. You get 10 raised to the power 10 here. 16, 6 is 96. So this is our answer in this case. Is that okay? So this way we solve the basic questions, and now you see one more point over here. Now they are saying how many electrons must be removed from a conductor so that it acquires a positive charge of 9.6 nanocoulomb. Now one point you should remember, that when we have developed a positive charge on the body, that means we need to remove electrons from the body. Now in case you are asked a question, is the mass of the body changed? Now we already know the mass of the electron is very, very small. What is the mass of the electron? It is 9.1 into 10 raised to the power minus 31 kilogram. So it is very, very small mass. So in case a few electrons are transferred from one body to another body, ideally speaking, there's hardly any transfer of the mass. But then, definitely some mass has got transferred. So if the positive charge has developed, some electrons have got removed from the body. So when a body acquires a positive charge, that means it has lost a small amount of mass. So in case you are asked a question on this, what is the amount of mass reduced in this case when the positive charge has developed? So if the question was there like this, in that case the mass that has got removed in this question would have been, the answer to that would have been N multiplied by mass of the single electron. So what is the value of N? N is 6 into 10 raised to the power 10 here in this question. And what is the mass of the electron? It is 9.1 into 10 raised to the power minus 31. So you multiply this and you will get answer in kilogram. Is that point here? And similarly, in case a body acquires a negative charge, it is because a few electrons have got shifted onto it, extra electrons have come onto it. That means its mass has got very slightly increased. So easy questions. In the next video, I'll come with few more questions. Thank you.